Hi, good morning. This is Prem Kumar, Assistant Professor, Department of Computer Science. Now we're going to see about the program a block move in 8085 microprocessor. We'll see the algorithm before we see about the program. So first what we have is we are initializing the register C with the number of bytes to be transferred. That is, if suppose we're going to move 5 bytes of data from one block to another block. So that is what we say it is in 5 bytes. That 5 bytes has been initialized in this register. And the second step, what we have is that is we be using the HL register path uh, to have the source memory location. So this is the memory location 8 HL. HL is going to have the register pairs of data. And again, we are initializing the register pair for the destination memory location. So move the byte from the source to destination from the HL register pair to the DE register pair. We will be moving the data by moving the data by move instruction and use to store that accumulated data to the destination. So take the data from the memory location and store it in the accumulator and move that accumulator content to the destination memory location, that is DE register pair. So we'll be moving each and every memory location of data. We'll be moving the every member location data, and the source data is been taking it. And then what we have is, so we'll be moving the each bytes of data from the memory location, and that source data has been moved to the destination pointer. So, and then last we'll be decrementing each and every movement of data from the HL register to D register pair. We will be decrementing the location by 111. So that is the purpose of decrement C register. So when it has become 0, it was telling that we have been moving that number of bytes from the HL register to the DE register. And this is a flow chart of this process. So we'll start with the program and initialize the source address with a starting address of the source block, and that destination address is also with that using the starting point to the destination block. And then we'll be initializing the counter variable for the length of block which is been moving from source to destination address. So getting the data from the source data and store that in an accumulator, and accumulator data has been again moved to the another register pair. So once we take in the data from HL to the register, we will be decrementing the counter by 1, and we used to check if the counters become 0. So this will be keep on going unless and until the counter variable C is going to be become 0. So if it is become 0, we'll stop the process and will come out. And then the next one is we'll see the program. This is the program part. So we have the starting memory location of 8000. And what is the first instruction we have? That is MVIC. That MVIC is immediate data 04. So we're going to take 4 data from the register from the memory location HL. So that is what the counter has been initialized as C. And the next is we have that HL register pair. The HL register pair is going to have the 4 values, and those 4 values is going to be moved to the D register pair. So that is what we have initialized that HL. We have initialized HL register and D register in the next memory locations. and we'll have that is move the memory location. The next address what we have, that is 8008. There we're going to move the data which is in the memory location HL to the accumulator. And after move that memory location to the accumulator, the next instruction what we have, that is STAX. That is, this line is going to take that HL register pair data has been moved to the memory location, and the memory location data has been moved to accumulator, and we are going to store that accumulator data to the DE register pair, that is the STAX. So STA is nothing but store the accumulator content, and X here is refers as DE register pair. So DE register pair, so it is going to accept the data from the memory from the accumulator to this DE register pair. So this is store the accumulator in destination location pointed by the DE pair, DE memory register. The next one, we will be incrementing the H and D. Why we are incrementing this H and D is, this is the source. H is referred here as a source, and D is referred as a destination. We will be incrementing the source location to 1 by incrementing 1, and destination memory location is also incremented by 1. So this is see this HL is equal to HL plus 1, and D is equal to DE plus 1. So next, what after incrementing the HL and D register pair, we will be decrementing the counter C. So first one data has been moved from the memory location HL to DE. So next, what we have to do is, we have to take the second memory location data from source, and that to be copied to the destination. So that is what we're going to do. And before doing that process, we used to decrement the C register. So it was initialized as 4, now it has become 3. So for what we have to do, the next process is we're going to check if there is any C 0. So jump not 0. What is the jump not 0 is, what is the register we have, that is C. The C register is not 0, then I can say B move. B move is nothing but we referred as a block move. So what is the address we are asking to go is, we'll be taking to the memory location 8008. So again it will come there, and what is the incremented memory location, and what is the data over there, and that data is going to be moved to the that data is going to be moved to the accumulator, and that accumulator content is going to store it to the memory location, that is the destination memory location. And after moving that accumulator content, and after storing that memory location content to the accumulator, and accumulator content to the DA register pair, we'll be incrementing the source location and the destination address, and we'll be decrementing the counter variable, that is to 2. So initially it was 4. After the first transferring of data from lower, that is from the DHL to DE, we have decremented the counter variable C, and again we are doing the third time we are doing that. So counter variable is going to be decremented by from 3 to 2. So this is what the process. Again, if it is going to check if the C register is 0 or not. If it is 0, it will stop the process. Otherwise, what it will do is, it will go there and move the memory location data to the accumulator, and store that accumulator to the D register pair, and will increment the memory location the HL, and also will increment the D register pair. Will decrement the C register, and this process is going to be continue unless and until the C register is become 0. If it is 0, what is the meaning of this? That is, we have completely transferred the HL register source data to the DE register destination memory location. So once it has been completed, we'll stop the process and we'll be coming out of the program. See this, the sample input and output. So we have the memory location data 31, 32, 33, 34 as E4, C3, B290. After transferring the data, after moving this block of data, okay, this block of data which is in 8031, 32, 33 is been moving to the destination address, that is 8041, 42, 43, 44, as the same data has been moved from the one location to another location. So the block of data which is in this HL, and it has been moved to the DE register path. This is the process of moving the block of data from one location to another location. Okay, so hope you all understand this. Thanks for watching. Thank you.